Welcome to Math Videotape 130B, Quadratic and Linear Equations, Work Applications. The concept for work is illustrated in the following example. Suppose that Kevin can finish his homework in 4 hours. Then Kevin can complete 1/4 of the homework in 1 hour. The portion of the homework which Kevin can complete in 1 hour is referred to as the rate. So in this case, 1/4 is Kevin's rate, meaning that Kevin can complete 1/4 of the assignment in an hour. Now, suppose Kevin works for 3 hours. Then he has completed 3 times 1/4, which is 3/4 of his homework. Therefore, when we multiply the rate by the actual time worked, we determine the portion of work that has been completed. So since Kevin worked for 3 hours and his rate is 1/4, 1/4 times 3 is 3/4 of the sheet. Now let's look at another scenario. If Kevin works for 4 hours, he has completed 4 hours times his rate, which is 1/4, equals 1, because the 4's cancel out. So that's one entire homework assignment, one completed assignment. So again, to determine the portion of work that has been completed, we take the hours worked times the rate. Okay, let's look at our first example. Doug can work the problems on his review sheet in 5 hours. Kelly can work the problems on the same review sheet in 3 hours. How long would it take them if they worked together? Okay, what's important here is that Doug takes 5 hours, Kelly takes 3 hours. Now that's Doug working alone takes 5 hours, Kelly working alone takes 3 hours. So those two numbers give us Doug's rate and Kelly's rate. So I'll put Doug and Kelly. In this column, I'm going to put the rate. So Doug took 5 hours. So that means that Doug can complete 1/5 of the review sheet in an hour. So Doug's rate is 1/5. And then since Kelly takes 3 hours to complete the review sheet, then she can complete 1/3 of it in an hour. So her rate is 1/3. Now the next column is going to be for time worked. Recall the rate times the time worked equals the portion of the work which is completed. Now, we were asked to determine how long it takes if Doug and Kelly work together. So that means we don't know how long they're working, but they're working together. So that means they're working the same amount of time. So I'll put X for Doug and X for Kelly since they're working together. And then for the final column, we follow our formula across the top. The rate times the time worked is the portion of the work completed by each person. So 1/5 times X over 1 will be X over 5. Then 1/3 times X over 1, multiply your fractions straight across, X over 3. So that means that Doug has done this much of the review sheet and Kelly will have done this much of the review sheet. Now we can use the information contained in this box to form an equation. What we would like is for Kelly and Doug to have completed the entire review sheet. So that means that the portion Doug has finished plus the portion Kelly has finished should equal 1. One entire review sheet. So we're going to add the two portions together and set it equal to 1. Now the technique for solving a rational equation, that is an equation which contains fractions, is to multiply every term in the equation by the least common denominator. The least common denominator in this case is determined by the 5 and the 3 here, which would be 15. So we multiply each term by 15. Okay, so multiply everything by 15. That's illustrated here. Now the purpose of doing that is to eliminate the fraction, so that's what we'll do next. 5 goes into 15 3 times. 3 goes into 15 5 times. And then we multiply what remains. So we multiply the 3 and the x, the 5 and the x, and the 15 and the 1, since nothing canceled out over on that side, and we get 3 plus 5x equals 15. Now this is a linear equation because there are no x squares in the equation. The only exponent we have is 1. So that's a linear equation. So for a linear equation, all we're going to need to do here is to combine like terms. 3x plus 5x is 8x. And then to isolate the x, divide both sides by 8. 15 over 8. And that reduces to the mixed number 1 and 7/8. And since the time frame for this problem was in hours, that means it takes 1 and 7/8 hours for the two of them working on the review sheet together. Now let's think about whether that makes sense. It takes Doug 5 hours by himself. It takes Kelly 3 hours by herself. So Kelly is the faster of the two. So that means that if Doug helps Kelly, it should take her less time than 3 hours, which is exactly what we came up with here. So our answer here should have been less than 3, since Kelly could finish the review sheet in 3 hours by herself. So with a little bit of help, it should take her less than 3 hours. All right, let's take a look at another example. Josh can stock the shelves with groceries in 4 hours. When Tyler helps, it takes them 3 hours to stock the shelves. How long does it take Tyler, working alone, to stock the shelves? Okay, so let's look at those times carefully. The 4 hours is the length of time that it takes Josh alone. So that 4 hours is going to translate into Josh's rate. The 3 hours is the time it takes with both of them. So that is not Tyler's rate. We are actually looking for Tyler's rate, since it says how long does it take Tyler working alone to stock the shelves. So again, we know Josh's rate. We do not know Tyler's rate. So let's take a look at how that's set up. Okay, so I'm going to put Josh and Tyler on the side, just like we did with Kelly and Doug. And then across the top, the rate times the time worked equals the portion of work completed.